Welcome to the discussion on questions 21 to 30 of SLMC 13. I'm not very sure whether these questions are in order, but you should be able to find the paper and then do them. And also, I'm not going to completely discuss every single matter because, again, you're here because you're interested in mathematics. So there are certain steps that I think you can do by yourself. So I will discuss the basic step and the basic thinking patterns for these questions, and you yourself are responsible to getting these small bits, small simplifications right. Okay. With that in mind, let's move on to the first question. So you have 120 different ways to arrange the letters S, L, O, M, F. Okay, and then the first one would be in the dictionary order or the alphabetical order. So when you have FLMOS, that would be the first word. And then 120th word will be SOMLF. So the question is, where does SLOMF appear? I think you'll have to think, okay, so when there's 120 ways of doing it, out of 120, the first 24 will start with F, and then the second 24 will start with L, then the next 24 will start with M, the next 24 will start with O, and then the final 97 to 120 will start with S. Because my word starts with S, it should be between 97 to 120. Now, out of these, what's the first word? The first word will be F, S, L, F, F, L, M, O. That's 197th word. And 97 to 102 will have the second letter SF. And then we will have SL, second letter, that would be from 103 to 108. Okay, 6 words. And then we can just count them, right? And then you have SL, and then OMF. So SL, the third letter, this would be 103 to 105 and so on. You can just keep writing. I think at this point it's immediate. You can better reason, but here you can say SLOMF. Let's write it down. Okay, SLF, SLF, and then SLM, SLM, and then SLO, SLO, FM, MF. Okay, so that would be the 108th word. Okay. Let's move on to the second question. So if you really thinking of like what kind of question this is, it would be a question on permutations and combinations and also counting things. The figure of the solid object. So let's move on to the question number 22. The figure of the solid object obtained by taking the cube of length, side length 2. Okay, and you can see only this part is cut. So you will have 3 of these things. And then the other side, the 3 faces are not cut. So 3 of these things, and then the triangle. And you need to see what is this area, and you can see because this is 2, this whole length is 2, so this is 1, 1, 1, which means this would be a 1, 1 triangle, which means this side would be root 2. Okay, and that would mean this side will be root 2 as well. And that would imply this side would be root 2 times square root of 3 over 2. Okay, you can use cosine 30, root 2 cosine 30, and because this is a SLMC 13, you should be able to also use the cosine things as well. So once you do that, well, the surface area of this would be 2 times 2, so that would be 4 times 3. And the surface area of this would be 1, 2, 3 and a half. So 3 and a half, or you can say 7 over 2 times 3. And this triangle is square root of 2 times square root of 2 times square root of 3 over 2 times half. And once you add all of them up, you're going to get 45 plus square root of 3 over 2. Okay, so it's just a matter of simply adding all these things. Okay, now this one right here. There are 13 railway stations between Colombo Fort and Gampaha. Actually, there are 13 railway stations. Find the number of different tickets that must be printed so as to enable the passenger to travel from one station to any other. So it includes Colombo Fort and Gampaha as well, according to the question. So there are total of 15 stations, and the ticket from Colombo to, let's say, Maradana is different from ticket from Maradana to Colombo. So the order would matter here, and you have to select two stations, the starting station and the end station. So order matters. That would imply you're going to use 15p, and 15p2, that would be 15 factorial over 13 factorial. This is going to be 210. So far we have easier questions, but compared to the questions 1 to 20, this is going to be a little hard. Okay, so let's see what Sasha, Tisha, and Jitu are up to. So they were on a hike and they were wondering how far away the nearest town. So when I say at least 6 kilometers, it could be 7, it could be 6, but it cannot be more than 6. So Sasha says the value should be from 6 to whatever number. And then Tisha says at most 5 kilometers. So 5 should be okay. Anywhere below 5 should be okay. But nothing uh, 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 outside that. And Jitu says actually the nearest town is at least 4 kilometers. So that would be 4 to infinity. Okay, now okay, so these are the ranges that they mentioned, but you can see that Sasha is telling a lie, which means actually the town should be from 0 to 6 kilometers away, but it can't be equal to 6 because Sasha is saying a lie. And same as this, Tisha tells a lie, so the town should be from bigger than 5 to whatever the value. And Jitu says it's from 4 to infinity, and this is correct. So what should be the correct interval where the set of all possible values? It should be the, like, because these things are true, it should be the intersection of all three intervals. Okay, because if they say okay, one thing is true, another thing is true, third thing is also true. So what would be the value where all these things are true? That would be the intersection of all these three intervals. And you can see that would be the interval 5 to 6. So this question is, you can keep intact, even if Jitu said didn't say anything, the same answer will be valid. Okay, the sequence A1, A2 up to so on satisfies A1 equals 20. So A1 is equal to 20. And for all n greater than or equal to 3, an is the arithmetic mean of the first n minus 1 terms. Okay, that would mean a1 plus a2 over 2 is equal to a3. And a1 plus a2 plus a3 over 3 is equal to a4. So whenever you get this kind of the general statement, substitute to first few things and try to get a pattern. Okay, and this will imply 2a3 is equal to a1 plus a2. So you can substitute that to a1 plus a2. So you get 2a3 plus a3 over 3 equals a4. So that gives you a3 equals a4. Okay, so now you smell a pattern, but you don't know whether this is correct. a1 plus a2 plus a3 plus a4 over 4 equals a5. But we know that a1 plus a2 equals 2a3, and then you have a3 here, and then you have again a4 is also equal to a3 equal 4. So you get a5. So now you can see a3 is equal to a5. And then you continue this pattern, you can see that a3 equals a6, a3 equals a7, and so on. So all these terms are the same. So a1 is 20, a2 we don't know, a3 equals a4 equals a5 equals a6 equals and so on. And we have somewhere this is equal to a9, which is 25. So a3 is also 25. So now you have a1 equals 20, a2 equals, we don't know, a3 equals 25. And substituting in the second one, you get 20 plus a2 over 2 equals 30. So a2 is equal to, 25. a2 equals 30. Okay. So let's get to the next question. Okay, this one is good. Savin is making a tower of cubes using cubes of strength 1 centimeters. And in the bottom, he glues n cube together. So n, and n. Okay, so altogether n cubed. And here n minus 1, n minus 2, all the way up to 1 cube. And he has used 2025 cubes. So when you look at it as an algebraic sum, you get n cubed plus n minus 1 cubed plus n minus 2 cubed up to 1 equals 2025. But this, I mean, if you knew anything about the year 2025, you should know that n is equal to 9. However, if you didn't know that, if you are an A-level student, you know that this sum is n over 2, n plus 1, the whole thing squared is 2025. So you get n over 2, n plus 1 is equal to 45. And this is the sum of first n integers, and you should get n is equal to 9. So you could have solved the quadratic equation, but again, you understand if this is the sum of all the first n integers to be n over 2, n plus 1, you can just reverse engineer that so that you can see n is equal to 9. So this is 9, this is 8, 7, 6, up to 1. So that would be the sum of all integers from 1 through 9. So the answer is 45. Okay, now this one right here. In the following addition problem, different letters represent different digits. And all indicated numbers are 3-digit numbers, which means these numbers C, T, A, B cannot be 0. Okay. And here you can see that T plus C plus T is equal to C. So T should be either 0 or 5. If you have 5 plus 5, then this addition works. So in this case, it's 5. So T is immediately taken to be 5. So T is 5 here. And you have C plus A equals B. So the numbers, I mean, you can't have 0. So you can have 1, 2, 3 as options, but not 4 for one of them. Okay. Because if you have 4, you're in trouble because you have to add 5 plus 4 plus the non-zero number. So the numbers can only come from 1, 2, and 3. So now it is all you have to do is substitute and see which numbers should work. And I believe the number 1 should work. If C is 1, you get 1, A, 5, 5, A, 1, A, 1, 5 equals B, E, 5. So in this case, for A, I can only substitute 2. Okay, so I can get 2 here, 2 here. And when I substitute 2 here, I get B equals 6. And then A equals 8, B equals 8. So that would work. And then C equals 2, I will get E equals 5, but E can't be equal to 5 because T is already equal to 5. So that option doesn't work. C equals 3 should also work. 1A 5, sorry, 1A 3, 3A 5, 5A 3, and then A 3, 5. So you get 3 here and 1 remaining. And let's say A is equal to 1. Hold on. Yeah, the maximum number A can have is 1, because if it is 2, you're gonna be in trouble. So this is going to be 9. A is equal to 1. So you have 1, 1, 3. That's and then you have plus 1 from the addition, so you get 9, 6, 3. So you can have either 1 or 3. Question number 8. Okay. So again, I will leave a lot for you to answer. I would say A1 equals 11. A2 using A1 would be A1 plus A1 plus Mn. So Mn is 1 times 1. So this is 11 plus 11 plus 1. A3 in terms of A2 would be A2 plus A1 plus 2 times 1. So this is okay. This would be A2. I'll have A1 here. Okay. And then this would be A2 plus 11 plus 2. And then A4 is equal to A3 plus 11 plus 3. And then A5 equals A4 plus 11 plus 4. And so, yeah. So here it would be, I'm using the fact that AM plus 1 equals A1, AM plus A1 plus M. And then you can subtract. So you get A2 minus A1 equals 11 plus 1, and A3 minus A2 equals 11 plus 2, and so on. So A5 minus A4 equals 11 plus 4. So, so you can now see that it all cancels out in this manner. And here you have 11. So you should get AN. Once you simplify, you should get n over 2 n plus 21. Okay, so there should be a fair bit of simplification involved here. So because you get an minus an minus 1 equals 11 plus n minus 1. Okay, because you get the same thing, an equals an minus 1 plus a1 plus n minus 1. And you can see that this is this part is n minus 1 over 2 times n. Okay, and then here you have 11n. So if you do the computation, you're going to get this. So for something, this is equal to 2025, which means you have n times n plus 1 is equal to 4050. So look for factors of 4050 that are 21 apart. Or you can solve the quadratic equation. You get n equals 54. Okay, because you have 54 times 75. 54 times 75 equals 4050. So that is 54. Question number 9. Again, I will not go through every step of the solution, but let me just tell you what would happen. So let's give this a name: A, B, C, D, E, F, and K, L, M. So you need to find Km. So you can apply the cosine rule for AEC. AEC to get that this is equal to root 7 over 3. Okay, and then you apply sine rule for this little triangle to find the values of the sine. Okay, and also sine rule for this triangle so that you can get this value, and then you should be able to work it out. So this one right here, I will not go into the detailed solution right now. I'm running out of time with my computer's battery. So let me just have it like that. Okay, use cosine rule and sine rule repeatedly. It is going to be a little bit of a calculation. So last one right here. Unfair coin has a 2/3 probability of turning up heads. Okay, if the coin is tossed up 50 times, what is the probability that the total number of heads is an even number? Now, what if you have like 6 coins? and you'll have like heads, heads, tails, 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 tails. So to have two heads, the probability is 2/3 to the power 2, but also you will have to have um, 4 tails, and that probability is 1/3 to the power 4, and because they are independent, you can multiply the probability. And then finally, we don't, out of 6, we don't know which two are the which two gives you heads. So it can either be like HT, something like that. So that means you have to select uh, 2 out of 6. So this would be the probability. So in the situation of 50, the probability of getting K heads would be 50C K 2/3 to the power K and 1/3 to the power 50 minus K. And then you will add 0 heads, you're gonna get 2/3 to the power 50. 2 heads, that would be 50C2 2/3 to the power 48. Sorry, uh, to the power, sorry. 0 heads, it would be 1/3 to the power 50. So let's go backwards. 50 heads, it would be 2/3 to the power 50. And then 48 heads, that would be 50C 48, and then 2/3 to the power 48 times 1/3 to the power 2. And then so on. 2 heads, 50C2, 2/3 to the power 2, 1/3 to the power 48. And finally, 0 heads, 1/3 to the power 50. And when you add it all up, you can see that it's precisely the expansion of 1/2 plus, sorry, 1/3 plus 2/3 to the power 50, but only the even terms. But when so if you want to compute that, you add 1/3 minus, sorry, 2/3 minus 1/3 to the power 50, and that will cancel out the odd terms, and you find the expansion of this, and then add it up, and you will end up with the answer half 1 plus 1/3 to the power 50. Now I'm planning to give a more detailed explanation, but I want you to try these questions first. And once I give a more detailed, once you have it, I will put a separate video on a detailed explanation on these few problems, because I think I would, for people who really want to do it themselves, this kind of explanation is enough. But then people who want to really learn by, looking at all those nitty-gritty stuff, I would write a detailed explanation for you. So I hope this is something that you find enjoyable. Uh, I hope you will do SLMC competitions in the future. There's one SLIMCC that also a competition that you can register and do. So you can that would happen on the 30th of March. I invite all of you to come and do the SLIMCC competition. This will happen in Colombo, Jaffna, and Peradeniya. I encourage all of you to go to SLOIMF website and do the SLIMCC competition if you really like or enjoy doing that. Thank you very much. I will see you soon.